where the borderline is between myths, fakes, and the truth. Can you hear? Can you hear me? Yes, we can hear you well. I have the first question for you. Now, a lot of people are talking about different fakes, about some are weird creatures like fishes with two heads, or apples in Chernobyl confinement zone, and various types of mutations that appeared as a result of Chernobyl, like animals with two heads or three heads. Actually, it is we have to separate several issues, myths. Big fish can grow that big even without any impact of radiation, ionizing ionizing radiation. That is the correct term for it. And actually, there may be only one reason for animals and fishes grow that big, because there is no fishing there actually, and the fishes can live longer and animals can live longer and grow bigger.
Тоді можна і прибрехати, вийде і всі 5 чи 10. На рахунок вроджених вад...
Regarding birth deficiencies, yes, sometimes animals are born disfigured and they don't live long when that happens. Like there are indeed two heads perhaps, or some extra limbs and some other degenerative changes. All of these things are simply to do with DNA deficiencies. DNA could be damaged, chemically damaged, for instance. But the key factor of DNA damage that may lead to the birth of such animals, and sometimes even happens with plants too, it's to do with ionizing radiation and its action, its targeted action on our reproductive organs. And when our body carries this to our progeny, it then, of course, is duplicated, replicated in the offspring. But there are indeed myths or distorted understanding to do with insufficient knowledge. They are not really, that they have nothing to do with what is taught at school. But for me, citizen of the country where the world's worst nuclear accident happened, it is important to know these things and be aware of this so that we don't spread fake information. Okay, well, we've got time to analyze the information and to explain to people the fundamental things about radiation. Well, let me ask you the first question. Is radiation always harmful? And the second question, what is the difference between radiation and ionizing radiation? Well, let's start by saying that the audience need to speak the same language, but any language indeed, changes as time goes by. Ionizing radiation, it may ionize substance, matter. That's why it's called ionizing. The word radiation is not quite correct. And so visible light, it's also radiation. And it is due to this, we can see this, we study optical facts, but we can divide this into two large groups. One group involves radiation of waves, such as visible light. So in this sense, we should not be afraid of this. Basically, all of this information we receive through eyesight. But electromagnetic radiation goes beyond what we can see. It has different range, and they have radio waves, for instance, infrared, ultraviolet. Then there's also gamma radiation and X-rays. These could, at a molecular level, do damage. That's why we can say that this is radiation, which most people would interpret as negative, as harmful radiation. And we can feel the after effects of this radiation. And usually the consequences are negative. The other group of ionizing radiation, that is high energy particles that can get inside the cell, penetrate it, and ionizing substance in the way, ionizing matter. And as a result, they can damage the structure of molecules and whole body. So there are electromagnetic waves, and not everything there, but only high energy radiation can be harmful. But particle radiation, again, in the past, Rutherford divided it up into alpha, beta, and gamma.
Зокрема, можна сказати, що найпоширенішими
Or
частинками,
we could say that the most popular ones to do with radioactivity are the particles such as electrons. They also call beta particles. They're basically elementary electrons. There are also beta particles, 2 protons and 2 electrons. There are also neutrons. They are also part of the nucleus of atom. So this is basically it. Their speeds are very huge. That's why they carry a lot of energy. And by sending those to atoms and molecules can change the structure of molecules. And in most cases, these are negative and lead to serious damage and death. So we shouldn't think of this as a flow of tiny balls this size of atom. They're very fragile, and they have huge energy, and they move at the speed of close to speed of light. Okay, where can a person receive this negative impact of ionizing radiation? Well, actually, we're receiving it on a permanent basis. If a person is thrown out into open space, for instance, away from galaxies, also sources of radiation, if I am in an isolated capsule, I will still be under the effect of gamma rays. Why? Because my body is also radioactive. There are some processes going on with the nuclear of atoms that can, but the main sources for us is, of course, nature, environment, and if we rank those sources in terms of how powerful they are as sources on our planet, of course, it depends on the location. And the first factor here is the air that we breathe, because it contains radon, which is a gas. It's radioactive, but we constantly breathe, and this radon radiates us from within, particularly lungs. So this is the key factor of natural radiation. Second source would be the land, the crust of the planet, because it contains radioactive isotopes such as uranium, also construction materials that our buildings are made of. And incidentally, radon comes from land. Land is the source of radon. So, especially if you don't live in a private house, but in a block of flats. So that's why this is one of the reasons why we need to air our flats. People say that there is Radon Lake in Ukraine. It looked great. And what's interesting is that people swim in this lake, which is enriched with radon, and they talk about positive impact radon plays, saying it's good for the state of skin, nails, hair, and so on. So, how true is this? Can you comment on this? Well, it's not just a lake, but remember in the Soviet days, people used to go to sanatoria and they would take radon baths, and they think that if that worked for people, then it should work these days too. But as we understand today, ionizing radiation for our bodies is hazardous. So, of course, swimming in such water is definitely wrong. Perhaps chemical composition of the water may yield one effect. For instance, if it contains lime or chalk or something else, it will affect the skin in a certain way, but perhaps sometimes a positive way. But I don't think it's got anything to do with radon. Okay, thank you for dispelling this myth. So let's go over this again. Its first source is the air. That's why we need to air the room where we live. Second source, I said, was land. It's the land, yes. By the way, granite, for instance, shouldn't be used inside the building because it's radioactive. So only external elements can be made of granite. But if you put dosimeter, it will show, for instance, radiation much higher. This is one of the reasons why granite should not be used at home. But also land, we also receive radioactive carbon and potassium and so on with food. You may have heard of banana equivalent. Regardless of where it was grown, for potassium 40, banana will contain that. Also, there's space radiation, of course. This is, but we live on the surface of the planet. We are protected by the atmosphere. So for us, the key sources are not the space, but if you go, say, 8 kilometers above land, there the level of radiation is a lot higher because there's less and less air above you. Plus, our body, of course, it's also radioactive. If you sleep in bed and someone else is sleeping next to you, it could be a higher level of radiation. Now, where within this hierarchy you would place Chernobyl, how dangerous it is for Ukrainians and Belarusians. Because both countries are located very close to the source of this accident. Well, we all understand that the quantity of cesium-137 half-life is 30 years. Only half of it has disintegrated. It still stays in the ground, and plants that grow there could contain this cesium, and then it can make its way into mushrooms and perhaps other plants and so on. That's why
За норму, норма це умовно. Це от ми визначили, що такий-то вміст.
The overall background is much higher. So it is indeed a very low level, and
Називається в честь французького вченого Анрі Беккереля. Це один
becquerels, which was actually named after this scientist. And in my body, I have 2,000-3,000
мало. Це дуже мало. Але якщо я з'їм чорницю з питомою
It's
активністю,
very low. But if I eat, say, a blackberry with containing 50,000 becquerels per kilo, the activity of my body will grow up considerably. And this cesium will end up in our muscles and so on. And in fact, the half-life of this would be about 100 days. And here's another myth, apparently that alcohol would drain the radiation out. All of this, of course, is not true. But unless you can calm down without alcohol, well, perhaps that's the solution for you. But it's one of the ways of relaxing yourself. But for people who turned off the sound, I can tell you for sure that alcohol doesn't help. And it cannot do anything about the radionuclides that have built up in our bodies.
Знаєш, це цей безперервний потік новин, як безперервний потік частинок з іонізуючого випромінювання. І просто я змушена це зачитати, і якраз це корелює із наступним питанням. В Німеччині більшість лісових грибів досі заражені радіацією Чорнобиля. Близько 95% зразків диких грибів, зібраних у Німеччині за останні 6 років, все ще містять радіоактивне забруднення внаслідок Чорнобильської катастрофи 86-го року, хоча його рівень не перевищує допустимих меж. Про це повідомляє Reuters. І, власне, за даними Федерального управління у справах захисту прав споживачів та безпеки харчових продуктів, підвищена концентрація ізотопів, якраз про які ми говорили, цезію-137 і цезію-134, викид яких стався під час аварії на ЧАЕС, була виявлена здебільшого на півдні Німеччини.
It was detected in South Germany. At the same time, none of the samples, about 200 samples, did not show any excessive amount of radiation. And that's where we shall try to understand. We talked about, I would like to repeat, we summarized and talked about different kinds of radiation and units of measurement of radiation. We're used to X-ray. We also hear the term becquerels and other terms. Let us try to figure out what are the units of measurements of ionizing radiation. If I ask my question correctly, thank you very much for your question. This is an excellent question. I would like to say right away that I am unable to answer this question in such a short time. Of course, we understand we are running out of time. Vitaliy is author of the blog Interesting Science on YouTube, and you provide very interesting explanations on your YouTube channel. The amount of radiation can be measured by such units as dose, and there are several types of doses, and the dose that is measured in Röntgen is about measuring the air, radiation in the air using various meters. If something is measured in micro Röntgen per hour, that is quite normal. And for Ukraine, the normal radiation level is between 10 to 30 microröntgen per hour. This is 1 millionth particle of Röntgen per hour. in 24 hours, of course, you have equivalent number multiplied by 24 hours, and then average annual dose can be measured. And I want to stress that this is quite normal level of radiation. What is the annual dose of radiation that is considered to be safe? And how to call it properly? Micro Röntgen. Röntgen is about the air. However, we are interested in measuring radiation and its effect on human health. Absorbed, and there is another way of measuring radiation. It is measured in Gray's unit, and it is the amount of radiation absorbed by a human body, depending on health condition. Well, you could say that you can absorb between 4 to 6 grays, and it will be semi-lethal dose. Average person would survive having consumed this amount of radiation with the probability of 50%. Or a person could survive, and it would take 2 to 3 months to recover. Actually, it is a small amount of energy. If you compare it with heating water, you could heat 1 kilogram of water by 1/1000th of 1 centigrade. It's a very small amount of energy. It's a tiny energy, tiny amount of energy, but it is sufficient to kill the body. For a human being, a detrimental lethal dose is between 4 to 6 gray units. Next way of measuring radiation is in Ziegert units, and the coefficient used is 20. For electrons, it can be different coefficients. From absorbed dose, you could calculate the estimated dose. Different parts of their bodies have a different different ability to respond and react to radiation. Also, weight and mass of the body is important too. If we talk about this equivalent dose, the safe radiation dose is between 0.5 sievert per year. It's the same as 6 gray. From 0.2 to 0.001 sievert. Basically, you can receive the same amount of radiation when undergoing X-ray of your tooth. It does not make sense for you to take X-ray scan often because it may be harmful for you. Tomography produces a certain amount of radiation. If a tomography test runs 10 minutes, you are going to receive the same dose of radiation as you are likely to receive in about 10 years of your life. So it represents a serious risk for your health. For example, tobacco contains radioactive polonium. Mammography also represents a risk. One mammography test is equivalent of 6 to 7 weeks of natural radiation. Actually, the usefulness of this procedure definitely exceeds the potential harm for your health. Thank you. This is really cool information in 10 minutes about where to go next if you want to find out more information. Natural radiation that you are likely to receive, it's between 2 to 3 millisievert per units per year. This is our natural radiation. What about absorbed dose? You mentioned this term. It is the energy absorbed by 1 kilogram of our body. It is measured in gray unit. Each kilogram of our body absorbs between 2 to 3 milligray units of radiation per year. Be mindful that I corrected myself. I talk about milligray units, not about sievert units, because it is going to kill you if you talk about gray. And there is another method of measuring it, radiation, taking into account its effective dose, taking into account the properties of different tissues in your body, because scientists prefer to use effective dose because it depends on the parts of your body and tissues, various tissues. What is the norm? What is the standard? For ordinary people, it should be between 2 to 3 millisievert per year, whereas for an employee of a nuclear power plant, it can be higher level. Different levels are established depending on risk and harm for your health, and such people receive extra pay for the danger, being exposed to danger, and they get retirement sooner, which is quite well understood. For pilots, the same conditions apply because they are closer to the sun, to the open space. Okay, thank you. Explain to me about Becquerel units. Becquerel is a French name, and it is important to understand that Becquerel is intensity of radiation. For example, he could put a sample into special radiation meter and close this equipment with a lid cover, and then calculate how much gamma units are likely to be attracted to it. And the higher activity it demonstrates, the longer you have to measure it. If your measuring unit is measuring something for a long time, it depends on the level of intensity. And the Becquerel is becquerel is used to measure intensity of radiation for products of natural origin like milk, berries, or mushrooms, and the standard radiation is between 500 to 600 becquerels per hour. This is a standard radiation level. Last question: how safe is it nowadays to travel to Chernobyl confinement zone? How safe it is for your health, including reproductive health? A lot of people may know that it is prohibited to visit Chernobyl exclusion zone, but it may represent risk for your health and your reproductive health. However, tourists which travel to this area, they are not exposed to risks, especially if they listen to instructions from the tour guide. If you go to Pripyat city and measure the radiation level, it may be not different from what you have in Kiev.